Hello again, welcome to the fifth module of the review of Calculus 1, this one entitled Rationalization of Algebraic Expressions. So in this pretty short video, we're going to see how either the numerator or the denominator of an algebraic expression can be rationalized by multiplying both top and bottom of the fraction by what we called the conjugate. Now, what's the conjugate? Well, the conjugate of a plus root b is simply a minus root b, and vice versa. So you change the middle sign when there is a root of some sort involved, and you have what is called the conjugate. So let's see if we can apply that technique on the first example here, which is 1 minus the root of x plus 3 over x plus 2. What is that equal to? Well, let's rewrite the statement of the problem. And let's multiply this by the conjugate of the numerator, which is the same thing as the numerator, but we change the middle sign. So the minus becomes a plus. And what we do to the numerator, we also do to the denominator. Good. So now we're going to expand the numerator, and we're actually not going to do anything to the denominator. So the top, 1 times 1 plus 1 times the root minus the root minus, what's the root of x plus 3 times the root of x plus 3? Just x plus 3, of course. And now downstairs, I am not going to expand anything, because if I do, I will lose every single chance that I have to simplify anything. And since the purpose of this is to simplify, I'll just leave it like that. Now, in any conjugate rationalizing expression, the middle terms always disappear. So what we have here is 1 minus x minus 3 over x plus 2 times 1 plus the root of x plus 3. Clearly, the numerator, 1 minus x minus 3, is really nothing else than minus x minus 2, isn't it? Minus x minus 2, out of which I can factor out a negative to simply get x plus 2 in a bracket. And there you see it, the simplification we were seeking is really just about to happen. Gone. Gone. Final answer, minus 1 over 1 plus the root of x plus 3. And that's how you rationalize an algebraic expression. Let's take a look at something perhaps a little more involved. So this time we have this guy here. What is this equal to? Well, we have definitely downstairs in the denominator root of x minus root of 5. So let us multiply both numerator and denominator by the conjugate of precisely this expression. So x plus 4 times the conjugate of root x minus root 5, which is root x plus root 5. All right. So what do we get? Again, the conjugates of one another are in the denominator here, not in the numerator. So this is the part we expand. The top, we will not expand. As a matter of fact, there's something I'd like to do to x squared minus x minus 20. It's a trinomial, so I'm going to try my product sum strategy here. I'll be looking for two numbers whose product is minus 20 and whose sum is minus 1. If you are coming up with minus 5 and 4, you're definitely correct. So let's see if we can rewrite this guy as x squared minus 5x plus 4x minus 20 times root x plus root 5. And here we're going to leave out the x plus 4, and we're going to expand the multiplication of the conjugates. Root x times root x, that's x. Root x times root 5, well, why should I complicate my life? I'm just going to leave it like that. Minus root 5 root x. And finally, root 5 is 5 with a minus, that's just minus 5. Lovely, lovely, lovely. So here I'll try to finish factoring my trinomial by doing the double factoring here, taking out an x minus 5, taken out a 4, and x minus 5 again. So that's times root x plus root 5 all over. As usual, conjugates, when they're multiplied together, have middle terms that cancel out. So I'm left with x minus 5 times x plus 4. So refactoring out from the top the common x minus 5, I'm about to see the light at the end of this short tunnel. X minus 5, x plus 4, root x plus root 5, tutta la familia over x minus 5 and x plus 4. Since all these brackets are multiplied, I can go x minus 5, x minus 5, x plus 4, x plus 4, and the answer that I get in the very end is root x plus root 5. That's what I want to box as my final answer. So one last example, this one really taken from a Calculus 1 problem. We would like to rationalize the expression here. How are we going to do that? Again, by multiplying by the conjugate. So here's the root of x plus h minus 2 minus root of x minus 2 over h. And we're going to multiply this with the very same thing. We don't change the signs inside the root, right? We only change the middle sign between the two terms. So this is what we're going to multiply top and bottom with root of x plus h minus 2 plus the root of x minus 2. All right, here the mutual conjugates are in the numerator. So I am going to have what? This times this is x plus h minus 2. Roots cancel out. Plus root of x plus h minus 2 times the root of x minus 2 minus the same thing. These are going to cancel as they usually do. And finally, root of x minus 2 times the root of x minus 2 is x minus 2 with a minus in front of it. And the denominator remains unaltered by our operation in the numerator. Tons of things are bound to happen, all of them in the numerator. So the usual shebang, the middle terms are gone, and I have a negative in front of a bracket, which I intend to bring in. So x plus h minus 2 minus x plus 2. That is all over h, and the denominator stays the same. Now what do we got in the numerator? We got x going away with minus x and minus 2 going away with plus 2. It appears that the only thing left is h, and conveniently there is an h downstairs for us to cancel in one little second. There it is, hence achieving our final answer, 1 over the root of x plus h minus 2 plus the root of x minus 2. And that is the final answer for this problem. And that's also the last problem of this short module.